So this is my home energy audit for the DSARI project for BBE 2201. So before I get into my home energy audit, we need to understand where energy comes from and what it's used for in the US. So 37% of the energy comes from petroleum, 29% of our energy comes from natural gas, 15% comes from coal, and 10% comes from renewable energy, and the remaining 9% comes from nuclear electric power. So as you can see on this graph, it demonstrates where the energy comes from and what it's used for. So for the purposes of this project, we're going to be focusing on electric power. So most of the energy for electric power comes from coal. So coal is a very carbon emission heavy form of energy. So I hoped by doing this project that I would understand how much electricity my apartment is using and be able to reduce that in order to reduce my carbon emissions. So the average electrical consumption for a household in the US is 897 kilowatts per month. This is dependent on household size, where the household is, how many people live in the household, and various other factors. So in Minnesota, the residential electric consumption is around 800 kilowatts per month. So this is less than the national average due to the fact that Minnesotans heat their houses with natural gas instead of electricity, which reduces the electrical consumption. So as you can see on the graph to the right, it splits up what electricity is used for in the residential sector. So the main ways that it's used is for space cooling, water heating, lighting, space heating, and then various other smaller appliances. So my apartment is the one that I measured for my home energy audit. So the building was built in 2002, and my apartment is 2 bedrooms, 3/4 bath, and it's around 560 square feet. So I do live in university housing, so I don't pay an electricity bill. So that means that I don't know exactly how much I'm paying for electricity or how many kilowatts per month I am using, but I called in and asked the building, and they said it should be around 200 to 400 kilowatts per month for an apartment of that size. So before I started my home energy audit, I measured how many hours per day I was using each appliance, as you can see on this graph. So my fridge is on 24 hours a day, but the other appliances that we're using a lot, that I'm using a lot, are my laptop charger, my phone charger, and my TV. So for my home energy audit, I didn't measure overhead lighting, the AC, and my dryer. There was various other smaller lamps and the microwave that I also didn't measure. So this is just a couple pictures of me doing my measurements. I used a kilowatt meter to do all my measurements, and I mostly measured constant power appliances. The only variable one that I measured was my fridge. These are just more pictures of me doing my measurements. So onto my data. So as you can see on the chart, the appliances that use the most electricity are my fridge, my washer, and my toaster oven. So this led to a total kilowatt usage per hour per day of 2.9, which meant 86.7 kilowatts per hour each month. So compared to the estimated monthly electrical use that I was given, I should say 200 to 400, my measured value was actually much lower, but this was because I didn't account for the electrical usage of all of my overhead lighting, the AC, and the dryer, which are all very large users of electricity. So my conclusions for my home energy audit. So in total, it accounted for around half of the estimated electrical usage in my apartment. This, like I said before, was due to the fact that I didn't measure some large consumers of electricity, such as the dryer, the AC, and overhead lighting. So what I did learn from this project was that a lot of my appliances are using phantom energy. So as you can see on the chart again, my printer is actually using a lot of phantom energy. So is my washer, and also my Keurig. So I'll be taking steps to reduce my apartment's electrical usage by unplugging these appliances when they're not in use and trying to turn off the lights when I'm not there, so I can reduce my carbon emissions from electricity. These are the sources for my presentation, and thanks for watching.